Start. Hello, my name is Saurabh Singh. Today I am going to explain the topic that is limit. Now let's start with a real life example. Suppose you have a pizza and you eat half of the pizza. So the remaining part will be this, and again you eat the half of that remaining part. So then the remaining part will be this, and again you eat the half of that remaining part, so the remaining part, and so on. So firstly the pizza is completely one, and after the one bite the remaining pizza will be one half, and after the second bite remaining pizza will be 1 by 2 to the power 2, and after the third bite the remaining pizza will be 1 to the power 3, and so on. So after the n bytes, the remaining picture will be 1 power to the power n, which is denoted by n. So the question is, when what happened if b increase the number of bytes? Does the picture completely disappear? So the answer is no. When b increase the number of bytes, the size of the picture gets smaller and smaller. That is approaches to 0 but never equal to 0. That implies completely never 0. So it is the motivation of the limit. So let's see mathematically. Suppose we have a function fx equal to x square minus 1 upon x minus 1, and x does not equal to 1. Now solve this. We can write like this: plus 1 upon x minus 1 upon x plus 1 upon 1 1 equal to. Now we will see what happened by the table. There is the value of x and there is the value of fx. Suppose we take a point 0.900. At this point the function value is 1.900, and again b approaches towards 1. So take point 0.990. The function value at this point is 1.990. Again take 0. The value is, the value of x is 0.999. The function value at this point is 1.999. So clearly we can see that when b approaches towards 1, the value of the function approaches 2. So this is the concept of limit. So let's see definition of limit. So limit of a function at any point, say a, is a value where our function say fx approaches whenever x get closer and closer to closer and closer to a. That means limit of a function is a value where our function approaches when b approaches towards a. Let us see by a 2D diagram. Let it, this is our x-axis, y, this is our function, this is the domain of function and the codomain. Let we want to evaluate limit at point A. Let take a point alpha 1 from left hand side, and we can see that the value of function at point alpha 1 is f alpha 1. Now B approaches towards A from left. Let take point alpha 2, the function value at alpha 2 is some f alpha 2, and similarly get more close to A, take alpha n which is near to A, and the value of the function at alpha n is f alpha n. From left hand side, when B approaches towards A, the function of the value of the function approaches to a point, say f alpha n, which is called the left hand limit, where our left, the value of left hand side approaches. And similarly take point beta 1 from right hand side, the function value at beta 1 is f beta 1, and similarly B approach from right, the function, the value of the function approaches a value which is called right hand limit. Then when the limit exists, we say that the limit exists if our left hand limit and right hand limit both are equal. That implies LHS equal to RHS. Now we'll see how to denote the limit. The left hand limit at x equal to A is denoted by limit x tends to A minus f of x. A right hand limit at x equal to A is denoted by limit x tends to A plus fx, and the limit of the function when the limit exists when LHS equal to RHS, and it is denoted, which is called the limit, and the limit is denoted by limit x tends to A f of x. Now we'll see an example. Evaluate limit x tends to 2 we evaluate left hand limit and right hand limit, then we will see if the left hand limit and right hand limit are exist and equal, then we will say that limit exists. Here the value of x is less than 2, that is by the property of mode we can write like this: minus of limit of x tends to 2 minus x minus 2, which go to 0. Similarly, a right hand limit at x equal to 2 is 0. So we can see that the left hand limit and right hand limit both exist and equal to 0. So we can say that the limit of the function fx equal to 0 at x equal to 2. So that's it for today. Thank you.